GRIAS Academy.
100 days, 100 themes, one goal, UPSC Prelims. Hello all, welcome back to our program Mission Surya, Phase 3. From today we are going to start a new program, STEM revision program, that is completely related to science and technology and environmental topics of UPSC Prelims examination. Okay, let's get started with today's concept. So today's topic is optical fiber technology. This is one of the important topic in science and technology related concepts because this optical fiber technology is a backbone of modern communication systems and which is generally used in internets, 5Gs and all for communications. We are using optical fibers, not relying on the old technologies. So that is why this optical fiber the optical fibers are important in regard of science and technology. This is generally frequently linked with current affairs plus technology development as of now. Okay, let us see the basic principle of optical fiber technology. The principle is, it works on the principle of total internal reflection where light gets trapped inside the core. And travels along the long distance with a minimal loss. This is what the total internal reflection means. Coming to the structure of the optical fiber. The structure it consists of a core. You all can see it here, this is the core. Oh, let me change the color. Okay, this is the core and this is the cladding part and this is the silicon coating and this is the buffer jacket. It has the strength membrane and outer jacket of a optical fiber wire. Okay, now see, in this core what happens is, which has higher refractive index. This core has higher refractive index which is surrounded by the cladding. Cladding will be surrounded by the core, where generally the light from here, consider light, the light first enters into core. After entering into the core, the light particles will vibrate and transmit to the cladding portion. From cladding, it transmits out to the system. Okay, now which is surrounded by cladding which has a lower refractive index. This core part has the higher refractive index and the cladding part has the lower refractive index. Next, coming to the properties. It is immune to electromagnetic interference. Which is highly secure and capable of carrying massive bandwidths. Not only single bandwidth or 10 or few bandwidths, it can carry a massive bandwidth compared to traditional copper cables. Okay, compared to our traditional copper cables, this optic fibers transmits the data faster, it gives high efficiency and high quality of the data, and it is capable of carrying massive bandwidths in a very less time compared to traditional copper cables. Okay, next. Not only like optical fibers are not only used in communication now, it is being used in a wider spread, like transformation of AI computing via optical fiber. Like, see, optical fibers are moving beyond not just data transmission to actively performing computer tasks, acting as next generation AI hardware. Okay, next, the data moves at the speed of light. See how fast the data is being transmitted. Okay, bypassing traditional electronic resistance. Optical neural networks can execute matrix multiplications almost instantaneously. Okay, now overcoming the memory wall. By overcoming the memory wall, what is it now? Like, traditional computing suffers from delays when transferring data between the processor and the memory. When transferring the data by using this copper cables and all, we see very delay in the data transfer and all. But now by using optical fibers, we process data as in transit as it moves, solving this bottleneck problem. Okay. This data transfer is being more faster when comparative to the old traditions of using copper cables. Energy efficiency. Photonic AI chips. These photonic AI chips, what they do? They generate minimal heat compared to traditional GPUs. Before we used to use GPUs in the place of photonic AI chips. Now what they do, when we use a system for half an hour or so, our systems get heated up. In that case, when we use this photonic AI chips, these gives minimal heat when compared to our traditional GPUs. They operate passively, requiring electrical power primarily for the laser rather than for trillions of electrical switches. Okay, this drastically reduces the need for massive data center cooling systems. Okay, next, see, massive parallelism. Then it is a light based computing. It is a light based computing. This is completely working on light. It is not now on electricity and all. Now it is using light now. So multiple wavelengths to travel a single fiber stimulus without interference, which gives accuracy also. Accuracy can also be dependent on it. Next, by leveraging non-linear optical techniques, light can effectively think, processing multiple layered neural networks faster and more accurately than silicon. By using light, more the processing is being fastened, the data transfer is being fastened, and the internet also is nowadays being fastened. Okay, now let's see the mechanism of optical fiber AI system. So it is on extreme learning machine. It is an extreme learning machine. This specific AI model replaces the traditional silicon chips by using the optical fiber itself. Okay, optical fiber itself as the computation or hidden layer. Next, data encoding. Input data like images are converted into numerical values. Images are converted into numerical values, are encoded onto light beams, which are encoded into light beams using amplitude and phase modulation across various frequencies. Okay. Next, let's see the physical processing. Coming to the physical processing, as the encoded light travels through the fiber, the light which is being encoded, when it travels through the fiber, physical phenomena like dispersion and non-linear effects naturally transfers the data. It naturally transfers the data. This physical mapping mimics the complex mathematical processing of digital neural networks. Okay, it reduces the physical mapping complex mathematical process of digital neural networks. Next, output generation. What would be the output generation now? The final processed data exists the fiber as a unique spectrum, which uses fiber as a unique spectrum of frequencies like colors, acting as a spectral fingerprint of the original input. Okay. Next, coming to the accuracy and tuning. This pure photonic processing achieves 91 to 93% of accuracy in image recognition. Okay, in image recognition, revealing traditional AI. However, performance is highly sensitive to fiber length non-linear strength. Too little results in weak computation, too much cause system instability. Done? Now, see, we have come up with few government initiative, one government initiative, which is BharatNet. What is this BharatNet? What is the target of the government by having this BharatNet initiative is, the government aims to deliver 1.5 crore fiber to the home connections. 1.5 crore fiber to the home connections nationwide under the BharatNet project, out of which over 14 lakhs connections have already delivered. Next, what is the main objective? The main objective is to ensure high speed optical fiber connectivity, fiber connectivity which reaches every rural household. Okay. Next, what is the impact of it? The impact is it acts as an enable for rural socio-economic development. Enables for rural socio-economic development, opening avenues in e-education, telemedicine in the health sector, smart agriculture, rural startups and e-commerce. This is the impacts by using this BharatNet. Basically, everyone needs net, right? Everyone needs net. With net, smarter things are being happening nowadays, like agriculture with drones, agriculture, the pest controls with drones and all. Like few of the things, like they can register. So many farmers are not registered for these in the MSP or what you say, this e-mandis and all, due to lack of this knowledge or due to lack of this what you call, this awareness. And net is also one problem. Many, when we go to the rural areas and all, we don't have our mobile signals. If the mobile signal drops, what happens? Net won't be connected. No net there. So to resolve few of these issues, the government has come up with the initiative of BharatNet, where the government wanted to provide 1.5 crore fiber net home connections. Until now, 114 lakhs connections are already delivered in the rural areas. Okay. Next. Okay. Next, moving on to the next topic. Our next topic is NAVIC, NAVIC. What is NAVIC? It is a basic this thing like navigation system. Like we are using GPS, right? So like GPS, now we have NAVIC, which is indigenously developed in India by ISRO, that is India Space Research Organization. So what is the objective? What is NAVIC? It is an India's independent standalone India's regional satellite navigation system, which is developed entirely by ISRO, India Space Research Organization. It is operating since 2018. It ensures India has complete control over its space segment, ground segment and user receivers, removing dependency on the foreign systems for strategic sectors. For many strategic sectors, we are depending on many other countries like GPS, which is being developed by USA. We are still being relied on it. So to reduce that dependency, India has come up with the navigation system of NAVIC. Okay. Next, let us. So we have seen what is NAVIC and what is it strategic independence. Now let us move on to the architecture and constellation, how it is designed. Basically, this NAVIC has 7 satellites. Okay, it is designed with 7 satellites. Make a note on it, friends, because it is of prelims perspective. Like UPSC may ask how many satellites are there, in which position they are arranged and all. So make a note on it if possible. Okay. So NAVIC has designed with 7 satellites, out of which 3 satellites are in geostationary orbit and 4 satellites are placed in geosynchronous orbit, which is inclined. Okay. Now, these 3 satellites which are present, the geostationary orbit satellites, what happened is they are fixed. They are fixed in a position and are relative to Earth. Okay. These three satellites which are placed in the geostationary orbit are fixed at a position and are relative to the Earth. Next, these four satellites which are placed in geosynchronous orbit, which is inclined, they are not fixed. They are not fixed to the relative of the Earth, but they will be moving in a 8 figure. They will be moving in a 8 figure. So, which 8 figure relative to Earth. Okay, and this NAVIC gives the navigations or specifications of India and the approximate area of 1500 kilometers also it can cover beyond India. Okay, this gives this which is the 3 satellites which are in geostationary orbit, they gives the perfect location, like it is used to measure the latitude, longitude and correct altitude of the location, whereas the geosynchronous satellites which are placed in geosynchronous orbit, these give a wider picture of the region which we wanted. Okay, now note, for systems like NavIC, to determine an accurate position on the ground, a minimum of 4 satellites must be in a line of sight, and the line of sight minimum 4 satellites have to be there. Basically, how many satellites do we have? 7 satellites, which is designed, the NavIC is designed with 7 satellites. Okay, remember this, for systems like NavIC, to determine an accurate position on the ground, minimum of 4 satellites must be in the line of sight to give you a correct altitude, correct longitude and correct latitudinal positions of the place. Okay, next, ground segment. This is we have seen in the space segment. Basically, this NavIC, I told you all, no, this NavIC is of 2 components, like space segment and ground segment. We have seen the space segment of the satellites. Now let us see the ground segment. Ground segment, it is supported by 24/7 network of control centers has been there with high accurate timing facilities. Okay, generally for timing in in the satellites we use time is being calculated, like I said already, like it is used for calculating latitude, longitudes, altitude of a place, and it gives the perfect time and all. For timing, it is using atomic clocks mechanism. Okay, atomic clocks mechanism is being used in the NavIC. For like monitoring stations are there, two-way ranging stations are also there, which provides us the perfect location and perfect altitudes, longitudes and latitudinal things of latitudinal data of a place which we want. Okay, next, see, global equivalents which are similar to our NavIC are the GPS which is developed by United States with how many satellites? 31 satellites. With how many satellites is our NavIC is developed? It is developed with 7 satellites. Okay, next, GLONASS is being developed by Russian Federation. Next, Galileo of European Union, BDOI of China, and one of our India's main another initiative is Gagan. Gagan is another Indian initiative where GPS aided geo augmented navigation, which is developed jointly by ISRO and the Airports Authority of India, primarily for aviation purposes it is being used. NavIC, it is for commercial purposes or local use of a people, but Gagan is for mainly aviation purpose they wanted to develop. Okay, next, I have already told you for calculating time they are using atomic clock mechanism. So let us see on what principle is this atomic clock is being used and what are its mechanisms. Okay, so it has 2 concepts, one is the core concept and the scientific concept. Coming to the core concept, an atomic clock measures time by monitoring the resonant frequency or vibration of atoms. Okay, resonance frequency or vibration of atoms. Based on these 2, the core principle of the atomic clock works. Coming to the scientific principle, atoms possess quantized energy levels. Atoms has quantized energy levels where electrons within these atoms also have electrons in it. Electrons within these atoms can only jump between fixed energy levels at high exact unchangeable frequencies. By these 2 principles, this atomic clock will be working. Next, every clock has a pendulum, right? Like that, the natural pendulum, what is the natural pendulum for the atomic clock is due to these fixed frequencies, elements like cesium-133 or radium, acts as a perfect natural pendulum for measuring time. Okay, next. How it works, how does this, we have seen the principle, on what principle does it works, and which natural pendulum is being used in the atomic clock. Now let us see how it works. It works as a microwave or laser source is precisely tuned. To the exact atomic frequency of the element. Next, a feedback system locks. On its frequency, the correct frequency where it can calculate the time, it locks on it. Okay, what it will be locked? A feedback system will be locked. Then the clock measures time simply by counting these continuous oscillation cycles. The natural pendulum is locked, and the time is simply calculated by the counting the continuous oscillations continuous oscillations of the pendulum. The time has been calculated, and everyone has a doubt now on based on these electrons and all, is the accuracy is too high, like can we rely on it, accuracy is good or what? We can have that question. For that, they are most precise timekeeping devices. In existence with an accuracy rate of losing or gaining only 1 second per million years. 1 second over million of years. This is what the accuracy of atomic clocks are, because of their extreme and unvarying precision. Atomic clocks are used to define the SI unit of time, which is the seconds. Okay. So, zero margin of error, we can frankly tell it has a zero margin, because you can see the accuracy is losing or gaining 1 second for millions of years. So, if this goes wrong in modern technology, even nanosecond errors can cause massive system failures, making this extreme accuracy indispensable. Next, everyone will be having a doubt. Now, let's first see the importance, then I'll come to it. The importance is the invisible backbone. It is the invisible backbone. They form the critical infrastructure for GPS, nav-IC, deep space navigation, telecommunication networks, and global synchronization systems. Okay, next, satellite positioning. In satellite navigation, atomic clocks calculate precise geographical positions by measuring the exact signal travel time from the satellite to the ground receiver. Next, coming to the terrestrial uses, they are essential for accurate vehicle navigation. Vehicle navigation, geographical mapping, land survey, and planning large scale constructions. Okay, now let us see what is the impact of failure. What happens if the atomic clock doesn't work in the satellite, right? What if an atomic clock doesn't work in the satellite? If it fails, the overall navigation accuracy of the network weakens, okay, significantly. Example, the failure observed in India's earlier IRNS-1F satellite. We have already faced this issue. So, now we are not at all ready to take up the issue like failure of this clock and all. So, we have come up with nav-IC with all the precautions and all. Okay. So, let us expect no failure would happen. Now, what are the efforts of India on it? Like ISRO planned this because to eliminate reliance on foreign imports for strategic assets. ISRO has successfully developed its own indigenous rubidium atomic clocks. I told you in natural pendulum, For the natural pendulum, we can use cesium or rubidium. So ISRO has used rubidium atomic clocks to be deployed in future navigation satellites. Okay, now let us come into the next topic. Our next topic is the world's smallest QR code generated. The world's smallest QR code is generated. Okay, what are these QR codes basically? What are these QR codes? QR codes are frames which stores our data, scans, it stores and scans the data. Okay. Now, GS1 new generation QR codes. What is the current context of it? Global transition GS1. GS1 is Global Standard Organization, Global Standard 1. So, a global standard organization has announced a worldwide implementation of new generation QR codes by 2027. Okay. Dual codes. Initially, product packaging will feature both the traditional one-dimensional barcode and the new two-dimensional QR code. Okay, this is a phased approach designed to ensure compatibility with older point of scale systems until retail infrastructure is fully upgraded globally. Okay, now you can see here world's smallest QR code sets a new record in Guinness World Record, which is created by researcher at Taiwan. The microscopic code measures just 1.98 micrometer in square. This recorded the world's Guinness Book of World Record. Okay. Now, a very small chip, this thing. What is this GS1? Global Standards 1. Global Standards 1 is an international non-profitable organization. Which mandate? What is the mandate of the organization is? It develops and maintains global data standards for efficient product identification, supply chain transparency and consumer safety. For identification, supply chain transparency and consumer safety. It is the main mandate of Global Standards 1. Next, what is the legacy of this organization is? The organization is responsible for introducing traditional barcodes nearly 50 years ago. Not now, 50 years ago, and currently operates it over in 100 countries. Okay. Now, GS1 India, Global Standard 1 and India, it operates as a not-for-profit organization which is established under the Ministry of Commerce and Industry, Government of India, which is responsible for developing and managing global barcoding standards domestically. Okay. Next, we have seen all this. Now, previously I told you one-dimensional barcode and two-dimensional barcodes. Let us see the differences. What is the technical evolution of one-dimensional barcode and two-dimensional barcodes? See, the traditional barcode, one-dimensional barcode, it is a machine-readable, visible representation of data using a pattern of lines. Okay. Popularly known as the Universal Product Code, as of now what we are using for a product. Okay. Next, where it is developed? It is developed in 1973 by George Laurer and Norman Joseph Woodland. These two people have developed this one-dimensional QR code. Next, as of now we are coming up with QR code 2D barcode. Every product generally we see on a chocolate or a cloth, and everything we have a barcode. Everything is digitalized. Previously they used to say this is this much. How much is this product means? They used to say 10 rupees. Now scan the QR code, the barcode, you'll get the price and you have to go for billing. This is what is happening. So The 2D barcode stands for quick response code. Okay, what is its mechanism? It stores data both horizontally and vertically, right? Horizontally and vertically. This two-dimensional structure give it a significantly larger data capacity when compared to one-dimensional QR code. Okay, when only store data, which only stores data horizontally, not vertically. It stores data only horizontally. This 1D barcode, horizontally it stores the data, whereas the 2D barcode, like two-dimensional barcode, stores the data horizontally as well as vertically. More data is being stored in two-dimensional barcode comparative to one-dimensional barcode. Okay, where it is origined? It is developed in 1994 by Masahiro Hara. Okay, Masahiro Hara, sorry. It is developed in 1994 by Masahiro Hara. So let us move on to the next topic. Our next topic is accuracy boost to weather forecasting technology, that is LiDAR integration. What is LiDAR? LiDAR is light detection ranging. It is a light detection ranging. Let us see on what principle this LiDAR is being worked on. The basic principle is it is a high accurate remote sensing technology that uses light information in form of a pulsed laser to measure variable distances from a sensors to the earth's surface or other targets. What happens in this principle is a laser of a light is released, it strikes the object, it reflects back and it measures the time. Okay, this is what happens in the basic principle of LiDAR. Okay, now let us see the working mechanism. What is the working mechanism? Basically, LiDAR works on the principle of time of flight. The system sends rapid laser beams. Rapid laser beams are sent, which measures the time it takes for the light to bounce back, means back scattering, and calculates the exact distance to the earth surface. Next, see the distance formula for calculating the time. The distance is calculated using the formula d is equals to c into t by 2. So d is the distance, c is the flight of time, and t is the time by 2. Okay, sorry, d is the distance, c is the speed of light, and t is time of flight. Okay, now the scanning method. The LiDAR can point in a single fixed direction or scan continuously across multiple directions, combining laser scanning with 3D scanning to build highly detailed spatial models. Okay, scanning method, we can see it is in a single fixed direction or scan continuously across multiple directions. In multiple directions it can scan continuously, and it combines laser scanning. It combines all the laser scannings with 3D scanning, okay, to build highly detailed spatial model. Next, moving on, let us see the core instrumentation and data processing. Okay, a standard LiDAR system often mounted on aircrafts, which are often mounted on aircrafts or drones, comprises three components, which has three components. What are those? First is the laser. As I told you, it emits the rapid light pulses, and the scanner or the object which directs the laser beam and records the reflected scatter light. In the sense, the laser is passing, it strikes the object and reflects back, right? In reflection, we have scanner where the direct laser beams are recorded, the reflected or scattered light. Then the positioning systems. The positioning systems uses GPS, global positioning system, to record the exact location, of the sensor, and then IMS. IMS is the inertial measurement system. To record the precise orientation of the scanner. Okay. Now, See the capabilities. Let's see the capabilities of the LiDAR. What are the capabilities? It uses light spectrum. It uses light spectrum. The LiDAR utilizes a broad spectrum depending on the target ranging from ultraviolet, which is approximately 250 nanometers, to visible light spectrum of nearly infrared, that is nearly approximately to 10 micrometers. Based on the object which it has to be detected, the spectrum will be changing. Okay. Next, the target detection. Because of its narrow laser beam, it can detect an exceptionally wide range of targets. It can exceptionally target wide range of targets beyond solid surfaces, including non-metallic objects, rocks, rain, aerosols, chemical compounds, clouds, and even a single molecule also it can detect. The LiDAR can detect. Okay. Next, it has a high resolution and accuracy. It can achieve terrain mapping. It can achieve terrain mapping from an aircraft with a horizontal resolution of 30 centimeters or better of it. Okay. It can create a 3D elevation models with an vertical accuracy of up to 10 centimeters. A 3D elevation is also can be done with LiDAR with a vertical accuracy of up to 10 centimeters. Next, canopy penetration. Coming to the canopy penetration, unlike some sensors, dense tree canopies allow partial LiDAR light to pass through the gaps and hit the ground, making it possible to map the earth beneath the forests. Okay. Next, let's see the data outputs. Coming to the data outputs, 3D point cloud is used. The 3D point cloud is the raw data collected is a dense point cloud representing all individual points reflected from every surface, that is either be a building, either be a leaves, either be ground, whatever it might be, it will be recorded. Next, the bare earth DEM. Coming to the bare earth DEM, by analyzing how much light energy returned, scientists can strip away structures and vegetation from the point cloud to create a highly accurate bare earth digital elevation model. Okay, highly useful for scientists. Now, let's see what are the type of LiDARs do we have. We have airborne or topographic LiDAR, we have bathymetric LiDARs, and we have terrestrial LiDARs. Coming to airborne LiDARs, these use near infrared light primarily for mapping landforms, for terrain creations and creating DEMs. Okay. Next, bathymetric LiDARs, what they use is they use green light. Okay. In the spectrum they use green light. Here they use near infrared rays they use. Okay, which penetrates water to map underwater terrains, to map the underwater terrains, shallow waters, intertidal zones, and near coastal ocean bottoms are also being trapped using bathymetric LiDARs. Okay, by using which light in the wavelength? Green light in the this thing. Next, terrestrial LiDARs. Terrestrial LiDARs are used on the ground, often mounted on tripods or vehicles for highly detailed ground level modeling and surveying. This is the terrestrial model LiDARs which we use basically. But this is a highly commercial one like bathymetric LiDARs. It can even map underwater terrains, shallow waters, intertidal zones, and near coastal ocean zones are also being identified by the bathymetric LiDARs. Okay. Next. The next is, let's see the comparison now. Why do we need LiDARs other than the other technologies? When comparing to the other advanced technologies, we will compare LiDAR to the radars. LiDARs provide much higher resolution than the radars, typically effective at shorter ranges. Okay, typically effective at shorter ranges. Compare it to cameras. What LiDARs does is, LiDARs provide direct 3D measurements. Direct 3D measurements means camera require algorithmic interference for depth. Okay, and functions perfectly in low light or dark conditions since it generates its own light. Unlike cameras need light, they cannot detect in dark conditions and all, but LiDARs can detect in dark conditions rather than cameras. Okay, this is what we can talk about the comparisons. Now, we'll see few applications of LiDARs and LiDARs in which areas they are being used. LiDARs are used in autonomous vehicles which is crucial for real-time navigation and precise obstacle detection because now we are coming up with smarter cars like automated cars, self-driving cars. So for those cars, they need a proper navigation because a driver can rely on the car when it goes completely on the basis of automation. Then it needs a crucial real-time navigation and precise obstacle detection. Any small obstacle also it has to be detected. For that, LiDARs can be used. Then in disaster management, according to disaster management, assessing hazards, mapping flood zones and predicting landslides. By these three causes, it can be used also in disaster management. Then in forestry and agriculture. In forestry and agriculture, as the laser lights are used, they can even enter into the forest. LiDAR light can be enter into the forest lands also. With the use of lasers it has been produced. So in forestry and agriculture also it can be used, like canopy or biomass analysis can be done, and precision crop monitoring or field mapping can also be done by using LiDARs. Then geospatial and infrastructure. How? By creating topographic maps, DEMs and precision 3D models for roads, bridges and minings. This can be useful in infrastructure model and geospatial industries. Next, in archaeology. In archaeology, how it useful in archaeology is it discovering hidden ruins and buried structures under dense vegetation. Next, geology and bathymetry. Monitoring terrain changes, hazard assessment and mapping seabeds. Okay, complete oceanography. Next, consumer tech. In consumer tech, how these LiDARs are used? These are integrated into smartphones for augmentation reality applications and faster camera autofocus. Okay, these are few advantages of LiDARs using in various industries. Okay, so that's all for today. I hope you liked this session. If you want a detailed note on this, do visit our website. The link is provided in the description below. And for your UPSC preparation, do follow our in YouTube channel. Do like, subscribe and do follow our Telegram channel and the Instagram channel as well. All the links are provided below in the description. Thank you for today and see you all tomorrow with another informative session of STEM revision program. Thank you.